Hello everyone. So first I would like to thank for giving us this opportunity. First I would like to tell you what is the understanding of the project we have and an understanding of the data set. The main task is to the challenge is to find the best fitting model to the given MC3 series. In total there are 1000 series. We need to split into 95% and 5%. 5% will be used as a forecasting test data set. We need to find the lowest Maze value for each series for that 95% training set, uh, which is basically divided into yearly, quarterly, and monthly period. We need to find the overall mean uh, minimum Maze for these periods and use the remaining 5% of each series to check the quality of our forecast. Use our best model to find the to calculate the Maze values over the forecasts for yearly, quarterly, and monthly period respectively, and finally find the overall average Maze values for each of yearly, quarterly, and monthly periods. So we have created a model function where we will be able to find out uh, AIC, AICs, AICC, BIC, HQIC, and Maze for various models. And so what we have done is we have tried this particular function with ANN, MAN, MMN, and MNN. We have passed these 5 ETS models to check how this function is running. We have run these models on yearly period covering all series. We have got the values as mentioned in the previous slide, that is AIC, AICC, BIC, HQIC, and Maze value. Basis the lowest Maze value, we have selected the best models, which is shown in the below snapshot. Uh, Also, we have extended this particular function to calculate the residuals basis Shapiro-Wilk test and Jarek-Barra test. What we have done is we have able to calculate the p-value for Shapiro-Wilk test and Jarek-Barra test for the best fit models, which has already we have shown in the previous slides for the entire series in the yearly period, showing a below screenshot. So these are the best fit models in the center column, which you can see, and you can also see the p-values of Shapiro-Wilk and Jarek-Barra test. We have created further two columns of if the p-value is greater than 0.05 at 5% significance level, then we say it a pass, otherwise we say it a fail. Similarly for Jarek-Barra test, and we have been able to get the residual analysis for the lowest Maze which we have got. Initial finding, we have done a frequency test. For the yearly period, we found ANN, MNN, and MAN to be the best fitted models among the 5 models checked so far for the entire series. So we are getting majorly these 3 models for the series in the yearly period. Shapiro-Wilk test shows 83% having p-value greater than 0.05 as a part of the residual analysis at 5% significance level. And so these are 276 models which we have got, where Shapiro-Wilk test is showing a p-value of greater than 0.05. So we can consider these models as the best fit models. Obviously for this one we have only ran only 5 ETS models, but once we do it for more models, then this will make more sense. As I already mentioned, for the rest of the models, we will reanalyze using other model fits and again check their residuals. So what is the approach going forward will be? We will run this model function with all possible models, not only restricted to ETS, maybe DLAG and adaptive and other models, for the 95% split data only, and derive the Maze value, then create a data frame of these models with lowest Maze value, which will be having one model for each series. So we'll be having 1000 lowest Maze values. On these 1000 best fit models, we will call them best fit models, we will do a residual check and calculate p-value for Shapiro-Wilk test and Jarek-Barra test. If the p-value of the residual analysis is greater than 0.05 at 5% of significance level, then these models will be considered as the best fit models. If the p-value of the residual analysis is less than 0.05 at 5% level of significance, then we will check the next lowest Bayes value for that particular series, that particular model in that particular series, till we get p-value of Shapiro Wilk test greater than 0.05. Then only we will consider that particular model for our final check. Uh, Finally, we will calculate the mean minimum Bayes value which will be derived for each period, and similarly we will test the best models for 95% test data set and run on the 5% forecasted data set and calculate the Bayes value, compare, evaluate, and finally conclude our finding in the final report. So that will be our approach. I hope we are on the right direction, and I'm really sorry for the delay, and thank you very much for giving us the extension. I really appreciate it, and hopefully we will be presenting and final report will be as per your expectation. Thank you so much.